All right, welcome everyone. As you start your careers in business, you might think that the most important things you'll learn are about marketing or big strategic frameworks. But I'm here to tell you some of your most powerful tools are actually rooted in math. So today we're going to ditch the abstract theory. We're going to see how basic algebra, stuff you've definitely seen before, becomes this incredible, indispensable tool for making real, high-stakes business decisions. The goal here is to connect those formulas you see in a textbook to the decisions you'll actually be making out there in the real world.
Okay, let's just jump right in with a classic problem. Take a look at this. I can absolutely guarantee you every single one of you will face some version of this scenario in your career. Now, when you look at this, your first instinct might be to just treat it like a math test question. I want you to fight that urge. This isn't just a math problem. This is a business problem, plain and simple. At its core, this is all about allocating limited resources, in this case your budget, when you have competing options. Every choice you make here will have ripple effects throughout your entire operation, affecting everything from inventory to sales forecasts, and you guessed it, your bottom line.
So here's our game plan for today. First, we'll go from dilemma to data, which is basically how to correctly frame the problem. Then we'll get into the language of linearity, which is just the algebra we need to describe it. After that, we'll apply it by modeling production costs. Next up, we'll use that model to find a break-even point, which is a super important skill for any manager. We'll also cover some key principles for accuracy to make sure we don't make costly mistakes. And finally, we'll wrap it all up by talking about the manager's math mindset, which is really about learning to think beyond just the numbers. Okay, let's get into it. The very first step, before you even think about plugging numbers into a formula, is defining the problem. This is absolutely critical. Think about it. Real-world business challenges are messy, right? They're often ambiguous with a lot of moving parts. This first step is all about taking that chaos and giving it some structure, turning it into something we can actually analyze in a clear way. And here's the real heart of the matter. The numbers on the screen, the $1,200, the $30, the $40, they're just data points. The real challenge for you as a manager is understanding the relationship between them. For every single unit of product A you decide to make, you're giving up the ability to make some amount of product B. That's a classic trade-off. In your economics classes, you'll hear this called opportunity cost. It's the value of what you're giving up. In operations, we just call it a constraint. And trust me, pretty much every important decision you make will involve navigating these kinds of trade-offs. So we understand the trade-off in concept. But how do we describe it precisely? How do we build a model of it? Well, for that, we need a language, and that language is algebra. Specifically, we're going to use what's called a linear equation. This is the moment we go from a vague qualitative business problem to a concrete quantitative model that we can actually solve. This is how we achieve clarity.
Okay, so this is the basic tool we're going to be working with. Now, the key thing to notice here is that the variables x and y don't have any squares or cubes on them. They're just raised to the power of 1. That's what makes it linear. In business terms, this means we're assuming a simple, straight-line relationship. The cost per unit doesn't change if we make 10 or 1,000. Now, is that always true in the real world? Of course not. Sometimes you get economies of scale, but this simplification is incredibly powerful because it lets us model these complex relationships in a way that's easy to understand and gives us really valuable insights.
This slide is where it all clicks. This is how we take that abstract formula, ax plus by equals c, and make it real. Let's map it directly to our problem. A is just the cost of product A, so that's $30. X is the number of units of A we decide to make. That's our decision variable. B is the cost of product B, $40. And Y is the number of B units we choose to produce. And C? That's our total budget constraint, $1,200. All of a sudden, 30x plus 40y equals 1,200 isn't just some random equation anymore. It's a sentence. It's a perfect, concise description of our business reality. All right, great. We've got the language down. Now let's actually use it. We're going to apply this model to a specific scenario to see how it gives us real, actionable answers to business questions. So, to make the math super clear, we're going to switch to a simplified model for a minute. Let's just imagine a tiny business where product X costs $3, product Y costs $4, and our total budget is only $12. The numbers are smaller and easier to work with, but the underlying logic, the mathematical relationship, is exactly the same as our bigger problem. This just makes it easier to see the mechanics at work. This right here is a question you are going to ask or be asked every single day as a manager. What if we do this? What happens if we commit resources over here? It's called what-if analysis or scenario planning. So let's run a scenario. Let's say we decide to make 2 units of product X. The big question is, how many units of Y can we still afford to produce? Let's walk through the math and find a concrete answer. And here's how the model gives us that answer, step by step. First, we plug in our decision, x equals 2. That gives us 3 times 2 plus 4y equals 12. Super simple. Then we simplify. That 3 times 2 is 6, so now we know that just making those 2 units of x costs us $6. Step 3, we figure out what's left. We started with $12, we spend 6, so we have $6 left for product y. This is basic budgeting, right? Finally, we solve for y. If we have $6 left and each y costs $4, we just divide 6 by 4. And there it is, y equals 1.5. No guesswork. The formula gives us a precise, unambiguous, and defensible number.
Okay, so far we've been dealing with one constraint, our budget. But what happens when you have to deal with 2 or more constraints at the same time? This is super common. In math, it's called solving a system of equations. In business, this is how you find that sweet spot, that optimal solution where you're meeting multiple goals at once, like hitting a production target and a profit target.
So, look at this. We're juggling 2 different business models now that we have to satisfy. The first one, x plus y equals 5, let's say that's our factory's physical capacity. We can only make a total of 5 units a day, period. The second one, 2x minus y equals 4, maybe that represents our profit goal for the day. So the puzzle is there one specific combination of x and y that makes both of these things true? That's our magic number, our optimal solution.
One of the best ways to solve this is called the substitution method. Let me walk you through the logic. Step 1, we take the simpler equation, x plus y equals 5, and just rearrange it to say y equals 5 minus x. All we're saying is, hey, whatever x is, y has to be 5 minus that number. Now for the clever part, step 2. We take that definition of y and we substitute it into the second equation. This is the key move because, boom, we've just turned a problem with 2 variables into a much simpler problem with only 1. Now it's just algebra. And you have to be careful here. This is where students often mess up. When you substitute, you get 2x minus the quantity, 5 minus x. You have to distribute that negative sign, so it becomes 2x minus 5 plus x. That gives us 3x minus 5 equals 4, which leads to 3x equals 9. So x equals 3. We're almost there. For the last step, we just take that x equals 3 and plug it back into our easy equation. 3 plus y equals 5. Well, that means y has to be 2. And there's our unique solution, 3 units of x and 2 units of y. That's the only combination that satisfies both of our business objectives.
Now, I just want to point out substitution isn't the only way to do this. There's another excellent technique called the elimination method. We're not going to walk through it right now, but it's really important for you to know that you have multiple tools in your toolbox. A good analyst knows both methods and understands which tool is the right one for the job at hand.
Okay, this next part is hugely important. A model is just a tool, and if you use it wrong, you're going to get the wrong answer. I see students make these same basic mistakes all the time, and I want to make sure you avoid them. Because in the real world, these aren't just mistakes on a test. They're mistakes that can cost a company a lot of money.
You absolutely have to get these down. Think of these as the ground rules. First, know the limits of your tool. If you see variables with squares or cubes, it's not a linear problem, and this kind of model just won't work. Second, be crystal clear about what your variables mean. Is x measured in units, or dollars, or hours? If you're not precise, your final answer is basically useless. Third, and I can't stress this enough, be meticulous with your algebra. That little negative sign we talked about, one tiny mistake there throws your whole result off. And finally, always check your work. Plug your answer, in our case x equals 3 and y equals 2, back into both of the original equations. If it doesn't work for both, you know you've made a mistake somewhere. Remember, a tiny math error on your spreadsheet can become a huge financial error for your company.
All right, let's pull back and look at the big picture here for a minute. The whole point of this lecture, I want to be really clear, is not to make you a human calculator. It's to help you start thinking about business problems in a new, more structured way.
This quote really gets to the heart of it. Getting the answer, finding that x equals 3 and y equals 2, that's not the end goal. That's just the start. The real value isn't the number itself, it's the insight you gain along the way. So what do I mean by insight? I mean understanding the rate of the trade-off. How much y do you give up for every x? That's the slope of the line. It's about asking deeper questions like, how would my optimal solution change if the cost of x went up by 10%? That is the kind of strategic thinking that separates a good manager from a truly great one.
And that leads us to this final question, which is really the big takeaway for your entire business education. The math gives you the hard, objective data. The logic of building the model gives you clarity on the relationships at play. But the math doesn't make the decision. The model doesn't make the decision. You do. These tools don't replace your judgment, they sharpen it.
They empower you as a future business leader to make decisions that aren't just based on a gut feeling, but are informed, confident, and strategically sound in an increasingly complex world.